Hello folks, we are here with the exercise 5.2 and this is our part 1 video. Now we have come to a totally new concept, that of derivatives. In the earlier exercise we were doing concepts on continuity. Now we are going to take up derivatives. Now we are informed about derivatives when we start this exercise. We know what derivatives is, but anyhow before we start, the derivative is, roughly speaking, given a function derivative at a particular point means it's the slope of the tangent that is drawn to that point of the function. Suppose if you have a function which is like this, some function like this, at a particular point when we draw the tangent, this is a tangent, this is a function, the slope of this tangent, that line, slope of that line is at that particular point is what is called as the derivative of that function at that point. So every time when they give us a function, it's not technically possible for us to keep on finding out this curve and getting the slope. So we have these ready-made rectangles with the help of which we are able to get the derivatives. So this rectangle, we should have it in our mind when we take the derivatives. We'll quickly have a look. Any polynomial function x raised to n has got a derivative n x raised to n minus 1. Now it's on the same lines, with the use of this n, that we've got this whole series, x raised to 2 n is 2, x raised to 3 n is 3, x raised to half means n is half, x raised to minus 2 n is minus 2, x raised to minus 1 n is minus 1. Trigonometric function sin x has got the derivative cos x has got the derivative minus sin x, tan x has got the derivative sec squared x, and sec x has got the derivative sec x tan x. E raised to x, our exponential function, has got the derivative e raised to x. E raised to x, whenever there is a coefficient along with x, then that becomes a into e raised to x. Now the same applies to the trigonometric functions also. If there is a function called sine ax, sine 5x, sine 10x, sine 2x, sine 4x, then the derivative will come as a cos ax. That means if it is sine 5x, then the derivative will be phi cos phi x. That way. Same way, cos ax will be minus a sine ax. Log x derivative is 1 by x. A raised to x, 2 raised to x, 5 raised to x, 10 raised to x. Such kind of functions has got the derivative a raised to x into log a. Tan inverse x has got the derivative 1 by 1 plus x squared. Sin inverse x is 1 by 1 minus root 1 minus x squared in root form. And cos inverse x is the same as sin inverse x but with a minus sign. Now, in finding the derivative, we also use the algebra. Like for example, suppose if two functions are added up and they ask us to find the derivative, sin x plus cos x. Suppose if they ask us to find the derivative, then you can individually find the derivatives and that will be the actual derivative of the function. Suppose there is a product of functions whose derivative we have to find. Something like x sin x, x into sin x, product of two functions, x and sin x. Then you can use the formula u into v dash plus v into u dash. I'll let you know how we use a formula. If there is a quotient also, there is a formula, quotient formula. If one is a function of the other, if y is a function of u and u is a function of x, then we use something called as chain rule and we find this. This is dy by dx. This is called as chain rule, and it is by chain rule that we are calculating the derivative. All that will look absurd as of now. Only when we solve it we'll get to know. So right away let's start with the exercise. This is our exercise 5.1 and question number 1 is sine x squared plus 5. Now as a rule we will always assume whatever is given to us as y, let y be sine x squared plus 5. Now we have learnt only the derivative of sine x. We don't know what is the derivative of another function, derivative of sine of another function we don't know. So that is the place where we are going to use chain rule. We are going to simplify it by another variable and then we'll further find the derivative of that variable and in turn we'll be able to find the overall derivative. So what we are going to do is, this is something new to us. If this is a linear thing, it will be easy for us. So we will make another assumption. Let u be that thing, x squared plus y. Now we can visualize what is y. This has become u, isn't it? So y is sine u. So both these are simple. This is also simple. This is also simple. So right away, let's calculate the derivatives. U is in terms of x. So we will find derivative of u with respect to x. Now how do we find the derivative here? You have got x squared also, you've got phi also. And every constant has got no derivative. Okay, that we have to keep in mind. Any constant a which fits a constant, it doesn't have a derivative. So we have seen if there is a sum or a difference, then you take it individually. So here it is like you take the derivative of x squared and you take the derivative of phi. That's how you do it, right? So derivative of x squared we have learnt. It is 2x by the formula nx raised to n minus 1. So this is 2x, and phi, because it's a constant, doesn't have a derivative. So like that, overall derivative is just 2x. Now, and y is in terms of u. So derivative of y with respect to u is going to be cos u. So both these derivatives are done. You have got to know what is dy by du, you have got to know du by dx, but that's not what we require. We want the derivative with respect to x, because function is given in with respect to x. So what we require is dy by dx. This is the place where chain rule comes to play. Dy by dx by chain rule is dy by du into du by dx, where du is our variable that we have introduced. So getting dy by dx is dy by du into du by dx. So how will that come? We have these values. This is cos u and this is 2x. U we will not keep it as it is. Why? Because it's our creation. We'll revert back. U for us is x squared plus 5. That's it. So our derivative is 2x times cos x squared plus 5. That's it. So we're going to use this logic throughout the exercise. So now our function given to us is y equal to cos sin x. Same thing, if it was cos something linear, it would have been easy for us. So we will assume that as u. Let u be sin x. So what is happening? This whole thing is becoming easy. Y is just becoming cos u. U is in terms of x. So you get the derivative of u in terms of x. Not at all difficult. Sin x, we know cos x is the derivative. So this is cos x. And y is in terms of u. Not at all difficult. Cos we know derivative is minus sine. So it is going to be minus sine u. Right? But then we want to, as usual, we want to get back to dy by dx. So let's see how we can get dy by dx by using chain rule. Dy by dx is dy by du into du by dx. So dy by du is there with you. It is cos x. So, sorry, it's minus sine u. And du by dx is there with you. It is cos x. So it is minus sine u, for us it is sin x into cos x. That's our derivative, right? In some sense you can get it directly from here. Cos derivative is minus sine of sin x, and because we have one more sin x, we should account for it. So that becomes cos x, right? Let's take this next question. That's very direct, because we have already written there y equal to sine ax plus b. As I said, if it was something linear, it would have been easy for you. So let's call that as ax plus b. So what has y become now? Y has become sine u. U is in terms of x. So let's take the derivative of u with respect to x. So it is derivative of ax and derivative of b. A constant will always move out of the derivative, as we had seen it in the limits. So a into dx by dx, which is 1, and derivative of a constant is 0. Like that, overall just a remains, and y with respect to u, derivative of sine is cos. So net effect dy by dx will work as dy by du into du by dx. So what comes up? Dy by du for us, it's cos u, and du by dx, it's a. So it is a cos ax plus b. Quite simple and quite easy. From the question itself, it's clear that this is how it is going to come. That's all about this, and we take more problems in the next video. Thank you.